Alright, this first question here is what I call just good old-fashioned algebra. Some kids were thrown off by that first set of parentheses. Is that first set of parentheses even necessary? No. We actually can just open them up. What's being distributed here? Just a positive 1, which doesn't affect anything. Is this set of parentheses necessary? Yes. Here you're distributing a negative 1. Okay, so let's just open up both parentheses. This would be 3x squared plus 2x minus 5x squared. Nothing changed there. Bring down the plus 8. Now this is definitely going to change everything that comes after it. So my next term would be minus 5x and then what? Minus 2. And now it's just a matter of like terms. What's the total of my x squareds? I've got negative 2x squareds minus 3x. Good. Those are done now. Not subtract 6. Plus 6. That's the simplified expression. Nobody's going to miss that tomorrow, right? Okay, now, factoring. Here is the deal with this one. The a times c here is what? 6. So we're trying to think of all the factor pairs of 6. Well, basically it's 1 and 6 or 2 and 3. Right? And we need it to add up to positive 5. Okay, so which pair is going to win then? 2 and 3. Okay, so that would be 3x squared. Now what would the signs be? Plus 2x plus 3x plus 2. Here's the problem. What's the GCF on the first two? X. And you'd be left with 3x plus 2. What do I take out of this? A 1. If there is no common factor, just take out a 1. And what's left? 3x plus 2. Now I can take out 3x plus 2, and what am I left with? X plus 1. Was that one down there? So what's the answer? None of the above. And you might even come across a situation where it can't be factored at all. That's what I thought was going to happen here. I didn't realize you could factor it. And if you can't factor it at all, then the answer would be D. The other choice you had was to guess and check the answer choices by using that FOIL business. This would be 3x squared minus 6x plus x minus 2. That's 3x squared minus 5x minus 2. That's not what I started with. It's close, but the signs are wrong. So if you are not a factoring person, try guessing and checking. This one would give me 3x squared plus 6x minus x minus 2. This one's closer. I get 3x squared plus 5x, but I still have the wrong sign on the 2. Try this one, and you would get 3x squared plus 6x plus x plus 2. So this one doesn't work at all because you get a 7x in the middle, not a 5x. So none of those choices worked, so you'd have to pick none of the above. Okay, let's try this problem. Now, I didn't have the space, but what they would do on a question like this is they would give you 4 different pictures. I had to put them all on. I had to get creative and put all the pictures on one grid. Read this and let it sink in for a second. If A and C are greater than 0. So we're trying to figure out which one, the pink one, the red one, the black one, or the green one. Which one could be function n, which is described as y equals ax squared plus c, and they tell us something about a and they tell us something about c. Remember, a controls the width of a parabola. Like fractions would make you fat, whole numbers make you skinny, or numbers bigger than 1 make you skinny. Positive numbers are smiles and negative numbers are frowns. So knowing about A tells me if it's a smile or a frown. And what's C? The y-intercept. What are they telling us about A and C? They're both greater than 0. Okay, well if A is greater than 0, which that means positive, is it going to be a smile or a frown? If A is greater than 0, it's going to be a smile. That means it can't be the black one and it can't be the green one because those are frowns. What else did they tell us though? C, which is the y-intercept, also had to be greater than 0. Why can't it be the red one then? Because it's on 0. Then the only one that's left is the pink one. That's opening up. The value of A is positive, and the y-intercept is 2, which is also positive. Purple, pink, whatever. Okay, now listen to this question. I'm going to change it. What if A and C were both less than 0? Then it would have to be the green one. Opening down, and then the y-intercept would have to be something smaller than 0, which is negative 2. Okay, let's talk about domain and range of parabolas real quick because it comes up a lot on last year's test. Any parabola, whether it's skinny or fat or opening up or opening down, the domain on just a plain old parabola that's not attached to a real life problem, the domain on a parabola on a quadratic function is always all real numbers. The range of a parabola is not all real numbers. The range of the parabola is the y values, and what controls the range? The minimum and maximum. The range of your function depends on where your vertex is, your minimum or your maximum. Look at this pink one or purple one, whatever you want to call it. What's the range of this purple one? Y is greater than or equal to 2. Because my lowest y value is a 2, all of the other y values are somewhere above that y value. The vertex controls your range. Domain is always all real numbers. Look at the red one. What's the what's the range of the red one? Y is greater than or equal to 0. 0 is the lowest y value. All the other ones are somewhere above it on that red one. All right, how about the black one? Y is less than or equal to 1. And how about the green one? What's the range of the green one? Y is less than or equal to negative 2, because all of the other y values are below that vertex of negative 2. They also do a question like this. What's the maximum value of that black parabola? What's the maximum value of the black parabola? 1. The value of a function is always its y value. What's the minimum value for the pink one? 2. The minimum value on that whole function is 2. What's the maximum value for the green one? Negative 2. So it's kind of the same. It's all about vertex. Okay, again, domain and range, a very important concept on this mock test. There is a big difference between the picture on the left and the picture on the right. Okay, and there's a big difference in real life situations as well. Sometimes when you're asked to give a domain, you actually have to list every single domain value. Sometimes it's not possible to do that, even if you really want to. The one on the left, this picture, this is called discrete. In other words, not continuous. Because these dots are not connected. If they were connected, this would be a whole different ballgame. But these dots are not connected. I can actually count them. How many domain values are there on this picture? 4. How many range values are there? 4. Now this graph is called continuous. Continuous means the dots are connected. There's billions of x and y values. There's no way we could list every single point that's on this line segment. There's millions of them. But what you can do is give me the lowest and the highest. Now this picture isn't perfect. It's really starting here at 0, 0. So, okay, you're getting on my nerves because you're not listening to me. Now, I am also going to go through some real-life situations, and you tell me whether it would be discrete, which means something you could actually count, or whether it would be continuous. Here are some real-life examples. Let's say that I am keeping track of how many basketball shots are made at a basketball game. Would that be connected dots like this one, or would it be just single dots? Single dots. That's called discrete. If I can count it, it's not going to be connected dots. What if I were measuring the growth of a tree over a 5-year time period? That's continuous, because the tree doesn't just jump from one height to the next. It's continually growing. What about if I was measuring milk being poured out of a container at different times? Continuous, okay, because the liquid measurement, it's not going to just jump from one amount to the next. What if I was keeping track of who's going to win the presidential election? It's discrete. If I can count them, it's discrete. You're counting votes. Yeah, if it's something that can be counted, whole numbers, it's going to be discrete. All right, let's talk about the domain of this picture here on the left. What's the x value of this point right here? -4. What's the x value of this point? -2. What's the x value of this point? 0. What's the x value of this point? 4. So in this case, it's the domain values are actually listed. All right, what about the range values? That's the y value. What's this range value? 0. What's this range value? What's this range value? -3. And what's this one? 2. Now, they probably would have them in some kind of numerical order. Now, much different situation when we come over here to this continuous graph. What's the lowest domain value? 0. What's the highest? 8. So this domain goes from 0 to 8, and all the other x's are somewhere in between. Now, how would that change if, at the end of this line segment, if I put an open dot instead of a closed dot? Then it would just be less than 8 instead of less than or equal to 8. And that's important as well. Alright, but let's put it back like it was. Closed dot, less than or equal to. What's the range values? What's the lowest range value? 0. And what's the highest? 350. And all of the other y values are somewhere in between. So big difference on how you report domain and range depending on the picture. Another thing that they ask about, and I'm trying to combine as many questions as I can here, is rate of change, which is another fancy way to say what? Slope. So let's look at this line segment. What's the rate of change of this line segment? The only line segment up here. This one. Okay, slope is just a number. Don't tell me x or I will scream. It's 50. The rate of change here is just 50. I just wanted you to get used to different scales. Because you know what some kids say the rate is? 1. Because they're going up 1, over 1, up 1, over 1. But the problem is every every y unit is not worth 1. It's worth 50. So you're going up 50 and over. Yeah, now this one's not perfect, I guess, because my line segment's not perfect. The main thing I wanted you to see is that you got to look at the scale. This slope would be real close to 50. Okay, good old-fashioned algebra. Here we go. Now, I just wanted you to see how this question would be asked. Some kids didn't understand the problem. I had one kid tell me, no, it's not true. They're just asking you, find the value of x that makes this equation work, that makes this equation true. It just means find x. It just means solve. And yes, there is a solution. right, did y'all agree with your shoulder partner? Let's see. I'm getting negative 2x. What comes next? Plus 9 plus 5x equals negative 6x plus 12. Alright, before you start collecting your x's together on one side, look at this over here. We need to simplify this side. I'm getting 3x plus 9 equals negative 6x plus 12. I'm going to move these negative 6x's over here to be with these positive 3x's. So I'm going to add 6x to both sides. 9x plus 9 equals 12. Now I'm going to move these 9's. Subtract 9 from both sides, and I'm getting 9x equals 3. Now, here's where kids make mistakes, down to the last step. I can't tell you how many kids tell me the answer to this is 3. Guess what they did if they got 3 as their answer? They divided by 3. But look at this problem. There's no way that 9 times 3 equals 3. Okay, what am I supposed to divide by? I'm supposed to divide by 9. I want 1x. So now I get x equals 3/9, which reduces to 1/3. Emily, did you get 3? Yeah, please watch out for that because they will put the answer 3 down there and hope that somebody falls for that, so be careful. Okay, remember these guys? Simplify that and leave it as a fraction. I don't want any negative exponents. Leave it as a fraction. Today is Took's birthday. Happy birthday, Took. Okay, now how does 12 over 8 reduce? You divide by 4. So it reduces like normal. So if you divide by 4, you're going to get 3 over 2. Now the way you reduce powers of the same base is you subtract the exponents. I think the easiest thing is to move them up to the top first and then adjust your answer. If anything ended up being negative, it's got to move back down. So I'm going to do 5 minus negative 3 for the A's. 5 minus negative 3 is 8. For the B's, I'm going to do 7 minus 4, which is 3. For the C's, I'm going to do negative 9 minus negative 4. Be careful. What's that? Negative 5. So where were those C's really supposed to be? On the bottom, and it would be C to the 5th. So that's what the answer choice would look like. How are we about those? Yes, you have to simplify the 12/8 as well. You know what some kids do is they subtract the 12 and the 8 because they know the rule for the exponents is to subtract, but that's not how you reduce 12/8. Okay, read this, let it sink in. Yeah, it's going to look for words like steeper, flatter. Okay, what do you know about this, oopsie, this function right here? Ugh. It's the what? Say it again. It's the parent function. F of x equals x, that's like y equals x. That's the parent function for all lines. The slope of that is 1. It's not steep or flat. It's right in the middle. And the y-intercept is 0. Now, we're going to come along and make the slope 2/5. So it's not going to be y equals 1x anymore. It's going to be y equals 2/5 x. And we're also going to change the y-intercept from 0 to -3. So the y-intercept's going to move down here. And then the slope's going to be 2, up 2, and over 1, 2, 3, 4, 5. What's going to happen? It's going to be flatter. So it got flatter, and it moved 3 units down. It got less steep or flatter. I don't know how they would describe it, but it definitely, the original one is steeper. The new one is flatter, and the new one is 3 units below the old one. Are you okay with that? So understanding y-intercept changes and slope changes. What if the slope had changed to 5? It would have gotten way steeper. And remember, if your slope is bigger than 1, you get steep. If your slope is less than 1, you get flat. Okay, now here's something new, guys. We are going to learn something new today, and I am going to count this one, even though we're just learning it today. Nick, are you with me? Okay, first of all, we have done linear functions till we're blue in the face. This is not a linear function. How do you know? Because it says it's quadratic. In other words, it's a what? It's a parabola. It's an x squared business. I don't know the equation, but I know it's a parabola. Now, where do we normally go if we know points but not an equation? Stat edit. Go to stat edit and put all of those points in. Now with the line, you just need 2 points. But with something that's quadratic, you cannot just use 2 points because a parabola is much more complicated than a line. So you have to put in every single point you're given. But if you know points and not an equation, we want to go to stat and put in those points. Stat edit, and then we're going to go to stat calculate, but we're not going to pick number 4 because this is not a line. Okay, so once we go to stat edit and we put in all those points, we normally, what we've been doing is choosing number 4 because we've been dealing with lines. But this is not a line. What did they tell us it was? Quadratic. So we're not going to pick number 4, we're going to pick number 5. And it'll tell you the value of A, B, and C. What's the value of A? What's the value of B? And what's the value of C? So then the equation would be what? Y equals 1x squared plus 4x minus 4. That's the equation. Now please listen, stay with me, folks. Domain of any parabola would be what? All real numbers. What are they asking us about? Domain and range. Domain we know. On a parabola, quadratic function, it's always all real numbers. Range depends on what? The maximum or the minimum, the vertex. I cannot tell the range of this function until I know the vertex. It's basically asking you to find the vertex. Now that we know the equation, where do we go? We'll go to y equals first. Go to y equals and put in the equation. because we have to find the vertex, because the vertex determines the range. Vertex and range go together for parabolas. Okay, so we're going to go to y equals, and we're going to put this function in there that the calculator found for me. Y equals 1x squared, or just plain old x squared, plus 4x minus 4. I just want to look at a picture of it for a second. My range values depends on the y value of this vertex way down here. That's the lowest y value. All the other y values are above it. Are you with me? Now, how do I find the vertex? Y'all are scaring me. You can do it in the calculate screen. Calculate what? This one's a minimum. You got to know if it's a smile or a frown. This one is absolutely a minimum. And it's going to ask you for a left boundary and a right boundary. When it asks you for a left boundary, just make sure your little blinky thing is to the left of the vertex and hit enter. Then it wants a right boundary. Make sure your little blinky thing is over here somewhere to the right of the vertex and hit enter. Make sure that vertex is in between your little arrows, and then when it says guess, hit enter. What's the lowest y value on this whole picture? -8. So what's the range of this function? Y is greater than or equal to -8. And actually this was the vertex showing right here. If you notice the vertex, the points start mirroring each other around the vertex because that's the turning point. Okay, so we were looking for this right here. That's the lowest y value. All the other ones are above it. Okay, find the y-intercept of this line. And you cannot tell me, oh, it looks like it's about 3.5. That's not good enough. Where in the world would we go to find the answer to this question? Where? Stat, exactly. Stat, edit, stat, calculate. This is a line. Now, they did highlight 2 points for you. What are the coordinates at this point? -1, 4. What are the coordinates at this point? 5, 0. So I know 2 points. I go to stat, edit, put my points in. Stat, calculate, find the equation of the line. And the only part I'm asking for on this one is the what? The y-intercept. Yeah, the y-intercept, the b value, should have been 10/3 or 3 1/3. And that's all they asked for. They didn't ask for the slope. What if they had asked for the slope? What's the rate of change for this thing? -2/3. Down 2 and over 1, 2, 3. Down 2 and over 1, 2, 3. So if they had asked for the slope, we would have reported -2/3. If they asked for the whole equation, Saul, then we would have put y equals -2/3 x plus 10/3. But you got to be able to answer the part that they ask for. They'll either ask for the slope, the y-intercept, or maybe the whole equation. Okay, how about some good old-fashioned algebra again? Do this. Yeah, this one has more just plain old equations than I've seen in a long time. Now, unfortunately, you cannot get rid of the fraction here because this is not an equation. You're going to have to deal with that -2/3. You're going to have to multiply -2/3 into the parentheses. If you don't know how to multiply fractions, use your calculator, but make sure you put the fraction in parentheses because a fraction problem is its own division problem. So you could do -2/3 in parentheses times 6, and your calculator will tell you the answer. And then -2/3 in parentheses times -5, and the calculator can tell you the answer. Emily, get busy. Well, a negative times a negative becomes a positive. I think of that as a -2/3. In fact, you could also do this. Make that plus -2/3. Okay, so I bring down the 8x squared. What's negative 2/3 times 6x? Negative 4x. Negative 2/3 times negative 5 becomes positive 10/3, and then bring down the plus 4x squared. And then you just look for chances to simplify. How many x squareds? 12x squared minus 4x plus 10/3. That's the simplified expression. Okay, now I want to talk about this one too, because we're going to learn something new here. Yes, they're calling this function function L. Function L depends on x, and this is the function rule. Now, there are two questions like this, and we had one like this on a CBA a few grading periods ago. They're going to ask you about the roots and the zeros. Because the factors and the zeros. Roots and zeros are the same thing. They're going to ask you about the factors and the solutions that the factors lead you to. So one thing I would do, the thing that's tricky about this one is we never practice factoring when you've got a negative sign in front of your x squared. We never really practice that kind of factoring. We didn't. Now, one thing you can do with 100% certainty in the calculator is find the zeros. Okay, so for sure you want to pick the answer that's got the right zeros, or the right roots, or the right intercepts, whatever they call them. Okay, so now let's remind ourselves how we do that. We go to y equals and we put in the function rule. Negative x squared minus 9x minus 20. And then you also have to put in y equals 0. And then you want to calculate where they do what? Intersect. Well, there is a way to just find the zeros, but you've got to give it boundaries, and especially in cases like this, the two zeros are so close together, it'd be really hard to do it that way. Okay, and then it says first curve, second curve, guess. And one of the zeros is at negative 4. Now, the other zero, it's really hard to tell here, but these zeros are super close to each other. I need to hit the trace and just scooch over a little bit towards the other side and do that whole thing again. Second function, calculate, intersection, first curve, second curve, guess. Negative 5 is the other zero. So those are my zeros, my roots, my x-intercepts. So you would pick the answer that has those listed as the roots. Now let's talk about the factors. Here is the way to find the factors. Let's just factor out the negative sign. It's very tricky to factor when your first term is negative, but what we can do is factor out a negative 1. In other words, just a negative sign. What's that going to do to every single term? It's going to change the sign of every term. So if it was negative, it's now going to become positive and vice versa. Well, these all happen to have been negative, so now they're all positive. Then you just kind of keep on bringing that negative sign down and then just ignore it and factor the rest like normal. What's a times c here? 20. What are the factors of 20 that could make a 9? 4 and 5. Okay, so let that negative sign hang out there. X squared plus 4x plus 5x plus 20. What can I take out of the first two? X, and you're left with x plus 4. What can I take out of these two? A positive 5, and you're left with x plus 4. Then you can factor out the whole x plus 4, and what are you left with? X plus 5. And don't forget what's out in front of the whole thing. These are the factors. Yeah, you can do that too. These are the factors, and what were the zeros again? This is tricky to me because of the negative sign. I would just find the zeros in the calculator and then just factor it. So factors, zeros, factors, zeros. They have two questions like that. One with a negative and one with a positive, so it's not as bad. Alright, let's keep on trucking here. Put this in slope, intercept, form. Then they might ask you to pick the graph that matches it. They might ask you what the slope is, what the y-intercept is. They might just ask you to write the whole equation. It just depends. Alright, first step is to move that 2x to the other side, right? So negative 5y equals negative 2x plus 10. Now, be very careful with your signs here. We got to divide everything by negative 5. So I'm getting y equals 2/5 x, then what? Minus 2. That's the equation. Maybe they'll ask you to find the whole equation. Maybe they'll ask you to match it to the right picture. This one would have a y-intercept of negative 2, and then you would go up 2 and over 1, 2, 3, 4, 5. So the picture should look something like that. What if they just asked for the y-intercept? What would you bubble in? Negative 2. What if they asked you for the slope? 2/5. Now what if it was a bubble in question and they asked for the slope? 0.4. If it's a fraction answer and they want you to bubble it, you've got to change it to a decimal. 2/5 as a decimal is 0.4. Okay, what is the rate of change of this linear function? First of all, are you told what kind of function it is? Yes, it's linear. Where do you go when you are given points? Stat, edit, stat, calculate. And yes, somebody pointed out we do know the y-intercept. What is it? 6. Okay, what is the rate of change? 9/4. Are y'all good with that? Or 2 1/4. And if you had to bubble it in, you would bubble in 2.25. Are we okay with this one? So lots and lots of easy questions on the mock test. Okay, this is something new as well. So everybody, wake up, sit up, look up. Let's make sure we understand this problem because it's very easy. One of the things that we haven't really done in depth is this kind of function right here. What is the domain of this guy? Look at the left and right. All real numbers. It's kind of like a parabola. It goes on forever to the left and to the right. Now, range is a little trickier. This arm of the function gets very, very, very close to the y-axis. So close you can barely tell that they're two different things. I'm sorry, to the x-axis. Thank you. But it will never, ever, ever cross the x-axis. It will never dip below 0, and it will never actually equal 0. So how would we describe this range then? All of the y values on this picture are what? Greater than 0. Not greater than or equal to, greater than. Let's say we moved this function down 2 spaces. Now, what would the red function's range be? Y is greater than -2. It will never quite touch this y equals -2 line. It'll get so close you can't tell. It'll look exactly the same, but it will never quite touch that. What if I moved it up to, well, never mind. I think y'all got it. Okay, this question. Now, I'm not sure I don't remember if this was a fill in the blank or a multiple choice. If it was a multiple choice, I wouldn't be worried about this one at all. Because you would just take the answer choices, plug them in until you get the right answer of what? Eric and Saul. This is for you. First of all, where do I put the 132 in this formula? For S. They're telling you what the sum should equal. 132. Now, I'm going to show you a way that's probably the easiest to do this. It just doesn't work on every single problem. We know the equation, so let's go to y equals and put the equation in. Y equals x squared plus x, basically, right? Now, we're trying to see when that function is going to equal 132. There's lots of ways to do it. We could turn it into a zeros problem. We could set it equal to 132 and see where they intersected. We could also look at the t-chart. The problem is you can't control what the y values will be. And we're talking about a y value of 132. Every once in a while you'll get lucky though. And you'll get a nice whole number value for x. When does this function equal 132? When x is 11. And I found it in the t-chart. Now, if you had an answer choice to choose from, when you get to this choice right here, you're going to plug it in. What's 11 squared plus 11? Well, let's see. That's 121 plus 11, which equals 132. So if this was a multiple choice, you could have just used the answer choices till you figured out the right answer. If it's not, try one of the ways that we've talked about. This one you actually will be able to find in the t-chart. Okay. Oh, we already did that. Find a factor of 25x squared minus 81. 5x plus 9 or 5x minus 9. They would have one or the other, not both. That's the difference of two squares. Okay. Remember, Waja, the middle term here canceled out. These two factors multiply to give me back this binomial. Let's see what happens. 25x squared minus 45x plus 45x. And then you would get a minus 81 on the end. And these two in the middle cancel out. Be nice. All right. I want to make sure you understand this problem too because it's very easy. You don't want to miss these easy ones. Y equals 5 parentheses 1 minus x. If I know an equation, I can go straight to y equals. Y equals 5 parentheses 1 minus x. Now what are they asking me to do with this? What is this supposed to be? No, y does not equal 7. Y does not equal negative 7. This is not a y value. That's an x value. They want you to evaluate this function at an x value of negative 7. What is it? 40. In other words, you're putting a negative 7 in for x. What's 1 minus negative 7? No. 8. And what's 5 times 8? 40. F of negative 7 means you put a negative 7 in for x. This is not a y value. That's an x value. All right. Inequalities. A lot of kids have forgotten about this. Do this very quickly. We're running out of time. Eric, you're never going to finish. Okay, first I distribute it. Now I'm going to add 8x to both sides. And subtract 8 from both sides. Now, it comes down to my last step here. And I have to divide by negative 2. The symbol better flip. I got x is greater than negative 1. Okay, what is the maximum value of this function? 4. What's the range of this function? Y is less than or equal to 4. That's the range. Okay, which one of these is showing y as a function of x? Which one is showing y as a function of x? This one is. Why? Why aren't these? Yeah. Oh wait, you know what? It's the x's that can't repeat, folks. The y's can repeat. All right, get a good night's sleep. That's your homework tonight. Get a good night's sleep and lots of rest and come ready for that mock test tomorrow.